Okay, guys, I'm going to go over how to calculate percent composition and then how to find empirical formula and also how to find molecular formula given the empirical formula as well as the molecular mass. Okay, this information can be found in Google Classrooms on the where this assignment is originally listed. There's 3 PDFs there that have examples worked through, but I figured this video might help some of you guys out. We have a quiz on Monday or Tuesday, depending on which period you have me for, which day you have me. Period 1 and 3 are on Monday, and period 6 is on Tuesday. Okay, just on these 3 things, right? Okay, so first, calculate percent composition. So percent, anytime you have a percent of anything over part over the whole thing, right? That's basically when we were looking for percent comp. Percent is just part over whole. So we need the part and the whole. Okay, so let's calculate the whole thing first. So the whole thing would be the molar mass Cl2O7. Okay, so we have 2 chlorines. So each chlorine is 35.45 grams per mole according to the periodic table. And then we have 7 oxygens. So 7 times 16. That's the molar mass of oxygen. 7 times 16. Okay, when we do that math there, we get, did the work already? I got 182.9. That's the whole thing. So I want to know percent of chlorine. I take the part, or the chlorine, so there's 2 chlorines, 2 times 35.5, divided by the whole thing, 182.9. That's going to give us a decimal, okay, and we just have to multiply by 100%, get the percentage. When we do that, we get 38.7. Okay, then for the percent of oxygen, it's 7 oxygen, each is 16, divided by the whole thing, 182.9, times 100%, and we get 61.24%. Okay, so oxygen is 61.24%, chlorine is 38.7%. You can always check to make sure that you didn't do anything wrong here. The percentages should always add up to about 100. Really, anywhere between like 99 and 101 is pretty acceptable. That all really depends on your rounding. Okay, so as long as it's close to 100, that's what matters. So that's percent composition. It's pretty basic, pretty straightforward there. Okay. Now, if we are given percent composition already, something like this, we can find the empirical formula. Now, the empirical formula is the simplest ratio of atoms in a molecule. Simplest ratio of atoms in a molecule. For example, let's say we have C2H6. Let's say, for example, this is not the simplest ratio of carbon to hydrogen. Okay, the simplest ratio would be CH3 because each of these numbers we can divide by 2. So that would be the empirical formula, CH3 of something like C2H6. Okay, that is the definition of an empirical formula. Okay, and we can find empirical formula if we're given percent composition. So getting back to this question here. So percent composition, we can actually find percent composition of a compound pretty easily using something called a mass spectrometer. Okay, and mass spectrometer will basically, if we put a substance into that mass spectrometer, it'll tell us the percentage of each type of element in the compound. Okay, now from that we can find the empirical formula. So there's a couple of different steps here. Step 1 is really simple. We just take the percentage and we change it to grams. All we do is just change the actual sign. So we have 69.94%. And we're just going to change that percent sign to a 69.94 grams. Okay, same thing with oxygen, so 30.06%. I'm going to change that to 30.6 grams. Okay, and The reason we do that, we just assume that we have a 100-gram sample of it. Okay, we're just going to say, okay, hypothetically, but that 100 grams, how many grams of each will we have? And simple as that. Okay. Number 2. So step 2. My handwriting is not bad. My computer just does that. I don't know why. In this one little area, it always does that. So step 2 is take the grams and convert it to moles. And we convert from grams to moles using the molar mass. Okay. So we take 1 over the molar mass of iron, which is 56. Okay. And then we do 1 over the molar mass of oxygen. So essentially, we're dividing each of them by their molar mass. All right. When we do this step, we get 1.252 and we get 1.879. Okay. Step 3 is to divide by the smallest number. So whatever number is the smallest, so here it's 1.252. So we divide by 1.252 and divide by 1.252. Okay, this one gives us 1, and this one gives us 1.5. Now sometimes this is the last step. If these two numbers are whole numbers, so if these are whole numbers, then we're done here. We're done. But if they're not whole numbers, as in this instance, we have to move on to step 3. Sorry, not step 3, step 4. Step 4 is simply multiply all the numbers by the same number to make them whole. So whatever you multiply these numbers by, they have to be the same thing, okay? So you can't multiply 1 by 2 and 1 by 1. You have to multiply both by either, this one, in this instance, we're going to multiply by 2. If we do this one by 2, we got to do this one by 2. Okay, so 1 times 2 equals 2, and 1.5 times 2 equals 3. And we're basically just multiplying it so we get a whole number, okay, because these are going to be our subscripts, okay, and subscripts cannot be decimals. Okay, subscripts cannot be decimals. So that means that, again, this is iron, and this is oxygen here. So that means iron will have a subscript of Fe2, and O will have a subscript of 3. Okay, so this is our empirical formula, Fe2O3. Okay, Fe2O3 is our empirical formula here. Okay, now this was 1.5, so anytime you have 0.5, you're going to multiply the numbers by 2. If you have 0.33 as a decimal, you're going to multiply by 3. And if you have 0.25, you're going to multiply by 4. Okay, typically these are the only 3 that you're going to have to deal with, so I wouldn't really worry about any other decimals. Sometimes they're not exactly 0.5, or exactly 0.33 or exactly 0.25, but they're going to be pretty close. So you're just looking for something that's pretty close to that. All right, so that's empirical formula. The last one is, let's say we're given an empirical formula and a molar mass. So we're given these two things, this and this. And we want to know what is the molecular formula. So the molecular formula is the actual formula of the substance. So the actual formula. So in order to do that, we got to figure out, okay, well, is this, so this is the empirical formula, is this the same as the molecular formula? So what we're going to do is we're going to look at the molar mass of the empirical formula and compare that to the molar mass of the molecular formula. So we're going to have molecular formula over empirical formula, and we're talking about the masses here, and we'll get a number. Okay, and that number will be the number we multiply the empirical formula by. Okay, so here, in order to find empirical formula mass, we use the periodic table again. So BH3, boron is about 11, and we have one of them, so just multiply by 1, plus H, there's 3 H's. We're going to multiply that by 1. That's the molar mass of hydrogen. Okay, and 11 plus 3 is 14 about, approximately 14. So the molecular formula mass was 27.7, and the empirical formula mass was about 14. When we do this, we get approximately 2. Yeah, I rounded this 11. Actually, 10. Really should be, not exactly that number, but whatever. It's close enough. Okay, so so there we go. The number is 2. So that's the number we multiply the empirical formula subscripts by. So the empirical formula was BH3. So we're going to multiply that by 2. So B2H6 will be the molecular formula. And bam, bam. Okay, simple as that. All right, that's it. If you have questions, feel free to email me, let me know. Otherwise, I'm out.